Welcome class to lesson 4.7 for Algebra 2. Today we're going to talk about transformations of polynomials. So have your notes ready to go in lesson 4.7. This part is not in your notes, but I want you to recall back in chapter 2. So chapter 2 in Big Ideas, we did a lot of quadratics, which were the parabolas. And when we had parabolas in vertex form, and this is vertex form, different numbers and different locations change the graphs. So if there's a number in the front of the graph, if it's positive, it opened up. If this is negative, it made it flip. So we call that a reflection over the x-axis. Also, if that number was bigger than 1, it would make these graphs stretch and make it super skinny. We call that a vertical stretch. If it was less than 1, it was a vertical shrink, and it made it nice and wide and flatten it out vertically. If the number inside the parenthesis here was just usually the opposite. So if this is x minus 2, the minus actually made it opposite. It moved it to the right. And if I see a plus sign here, it moved it to the left. And then if there's a number on the side, this is the number that made things go up or down. So if it was a positive 5, it would go up 5 spaces. And if it was a negative number, it would move that vertex down that many spaces. So I want you to keep this in mind because we're going to use the same idea, but this time polynomials. It could be a cubic, a quartic. So the graphs are going to look a little different, but the concept of a transformation is going to be just like parabolas, just like all these quadratics, okay? So take good notes and pause whenever you need to and fill in these little tricks and hints to remind you to complete your assignment and your quiz and test, okay? All right, so this is in your notes. I'm going to just highlight a few things just to help you remember. Look how they write things. So this is the function notation. So the first one here is if any number is inside, notice inside with the parentheses, this is the one that makes things go left or right, okay? So try to think opposite for me. So whenever you see a minus sign, that's to the right, and then plus sign is to the left. So write yourself a note. It really is the opposite direction, but left or right. So use a left or right arrow, right, left or right, and it's grouped together with the X, okay? The next thing we want to look at is things that are separate. It's on the side. It's not, the exponent is separate and there's a number on the side. That's the up or down part. So the separate number is what you see. A positive will go up, a negative will go down. So write yourself a note to remind you how many ways. So I'm going to go through all these transformations. We're going to do the algebraic, but on your assignment, it does ask you to not only describe, but also match the graph. So you need to select the correct one that matches these transformations as we describe them. Okay. For reflection, we're going to concentrate on the x-axis. So go ahead and cross over the y-axis. This year, we're going to concentrate on over the x only, so that flip over the x-axis. So this is saying you're going to distribute the negative sign in the front of, not inside the parenthesis with the x, but in front of. So I'm going to multiply everything by a negative 1. That makes it flip over the x-axis, okay? The word that you will use to describe this transformation is reflex over x-axis, okay? Or you could use the complete word reflection over the x-axis. All right, now we're going to talk about that vertical. Again, we're going to stick to the vertical, not horizontally. So we're going to stick to the vertical switch. We're going to go down here. If it's a number in the front of the equation, notice it's around this f of x, which is the whole equation. You actually multiply the whole equation by that number. If the number is bigger than 1, it's going to make things stretch. So it's going to look super skinny. So vertically stretching a rubber band vertically, it's just going to make it look skinny. Okay. And if that number is less than 1, it's going to be a vertical shrink. So when you describe your transformation, you actually say the word vertical stretch by, and then there's the number, or vertical shrink by, and then it's the number in the front. Okay. So we're going to show you some algebraic examples in a moment. Remember, pause and go ahead and write out all these details, kind of like little hints to help you recognize transformations. All right, so let's start with these. I selected a few problems to try. So here's the original equation right here. And then the new equation is here. It says describe the transformation. So the change, transformation is change. How did the original equation f change to get to g? So the only difference between these is this minus 9. So what did that minus 9 do to the graph? So you have to decide, is it together with the x or is it separate? And here, it's not inside x minus 9 with the power of 4, it's actually separate. So this one is down 9. I like you to write the word down, but also include the 9 whenever you're talking about. So there's going to be numbers everywhere. So include the actual number with the description. Okay? All right, let's take a look at number 2. The original problem is this odd x to the fifth polynomial. And then there's two things that's different. There's this x plus 1 here, and then there's a plus 2. So you want to describe what those numbers do. So first off, what does that plus 1 do? Try to take a guess. If you need to go back to that chart, go ahead and do so. And then take your best guess before you continue. All right, so this is the horizontal translation. So translation is a sliding left or right. You have to decide, is it left or right? Remember, think opposite, all right? So this one is actually left one space. And that separate plus 2 is going to make us go up 2. I hope you are a step ahead of me, up 2. Okay? All right, 2 more to do together. In example 3, want to take a look at this x to the 6th power. So what do these separate numbers do to the graph? And inside, it's a minus 2. So inside the parenthesis, you want to do a horizontal slide translation to the right 2 spaces. All right, so we're going to slide to the right 2 spaces. Now, the number in the front is actually 2 separate things, okay? There's a negative sign and the 5. You want to treat those as 2 separate things for me, okay? So just think of the 5 separately, all by itself. This is going to change and make it either stretch or shrink. Okay, so you need to decide, is that bigger than 1 or less than 1? Just the 5, not the negative, okay? Since that 5 is bigger than 1, it's going to be a vertical stretch. So this is going to be a super skinny graph stretched out. Now, let's look at that negative sign all by itself. When I think people are negative, well, they're sad. So it's going to make things flip around. And the word we use is reflect over the x-axis. All right, so there's going to be a reflection over the x-axis for this problem. So there's 3 different transformations for this particular polynomial. All right. All right, very last one. I want you to try this on your own. I will give you a hint on this one. There are 2 things, okay? So this minus 10 does something to the graph, and this plus 1 does something to the graph. Let's see if you can identify those 2. Pause the video, and then try it. Write it down, and then continue the video to check your answer. All right, I hope you got a chance to check it, and let's see how did you do. So that is to the right by 10 and up 1. How did you do? I hope you got it okay, since we did a lot of these with quadratics before. All right, our next objective is to actually go backwards. They're going to write down the words of the transformation, and you're supposed to write a rule. Write a rule for G that represents the indicated transformations of the graph of f. So a rule is another word for equation. We're going to write an equation. I'm going to simplify this equation a little bit. So I'm not going to actually cover up. I just want to make it basic for us right now. If all those are there, it's a little bit more complex. So I want to make it basic. Our basic starting equation is going to be x cubed. So this is going to be a cubic function. Ready? Want to add on these numbers. I want a number placed in the correct spot so it shows that it's going left. Okay, so you need to decide, is that the number in front grouped inside the parenthesis, or is it a number on the side? Okay, so I'm starting with the original equation. I am going left. So left, right is horizontal. That's actually inside the parentheses. So inside parentheses, do I do x minus 1 or x plus 1? All right, so horizontally, I hope you remember it is the opposite. I want to go left, so I should see plus 1. Okay? All right, next thing is reflection. I'd like to flip this polynomial around over the x-axis and to do a vertical a reflection over the x, it's a negative in front of the parentheses. Okay? And then lastly, it says a vertical stretch by a factor of 2. Vertical stretch by a factor of 2. So I'm supposed to see a 2 somewhere. And for it to stretch vertically, I have to put it in front of the parenthesis. That is it. We are done. Notice that negative sign is still there. So that negative is still showing that reflection. That 2 that's bigger than 1 is going to stretch it by 2. And I can see plus 1, so that is left. So if you're done with your final equation, you should be able to describe all these words for yourself. And that's a good way to check your answer. Okay? All right, we have one more to try together. So ready? Yeah, I'm going to make a little bit of change on this one. The original problem's a little bit more complex, so bear with me as I kind of tweak this problem around. So again, I'm going to cover that up just to simplify our problem. We're going to concentrate on 3x to the 4th power. Okay, and another thing I'm going to change, instead of horizontal, remember I cross out the horizontal, we're going to concentrate on the vertical stretch, right? This year we decided only to teach vertical stretch. So let's go ahead and we're going to keep that as a vertical vertical shrink by a factor of 3. Now, since it's vertical, remember you have to decide, is it the front, inside parenthesis, or on the side? Vertical stretch or shrink is actually in the front, and we're going to multiply in the front. So I'm going to take that equation and I'll multiply it by 1/3. I want to take 1/3 of 3, okay? And 1/3 times 3 is actually 1. Now, if I didn't delete or cover up the rest of this polynomial, what I would have to do is multiply and distribute the 1/3 to each and every single term. Okay, so that's not so bad. If I want a vertical stretch, let's say by 5, I would have multiplied everything by 5. Okay, so please keep that in mind. I think in big ideas, they have a few problems where I'll make you do that. So write yourself a note. If there's more than one thing for the vertical stretch or shrink, you are going to distribute. You're going to multiply everything by that factor. Okay? All right, so now we have this graph here. It says, please translate it down 8 units. So we have to decide where should we put the 8. Is it together with the x in parentheses, or is it on the side? Okay, so down 8 spaces. I hope you recall that it is on the side. So -8 will show me it went down 8 spaces. Now, order does matter. I'm going one at a time. It says do this, then this, followed by. All right, so last thing, I'm going to take this equation here and I'm going to reflect it in, oh, you know what? We don't do y-axis. I'm going to go ahead and switch that to the x-axis. Remember, we concentrate on the reflection over the x-axis. We're just not teaching the y-axis for this year, okay? All right, for this one, before I continue algebraic, I want to show you what this looks like graphically. So far what we have is we have this with a vertical shrink of 1/3. So we have this. Then we did -8. So everything, notice it goes all the way down here. It does look like a wide parabola, doesn't it? That's what a 4th degree does. It stretches it out as a 4th degree, all right? So this is what I have so far. Now, I like to take this graph here. Lastly, it says reflect over the x-axis. So my x-axis looks like this. Oh my goodness. So reflection, I'm supposed to multiply the front, but look how I put parentheses. All right, makes sense. My vertex is down here because it says pull down 8. But if I flip this, remember in geometry, when you do reflection, it just bounces over that reflection line. So if I flip this over, it's actually up here 8 now. Look at that. My new graph is up here. So it's still reflection. Okay, so now look at my final equation. I do have to distribute that negative sign. Isn't that funny? So I distribute, I get -1 in the front, and I distribute, and now this is a +8 because I flipped it over, and that's where my vertex is. Okay, so if you follow the directions from step to step to step, this is our final graph and our final equation. Okay, so things that to remember. If there is a vertical stretch or shrink, you multiply every single term by that number. Also, if there's a reflection last, you have to also distribute that negative. So order does matter. If this reflection was way up here, then I would not distribute. If this reflection is the first step, this would be negative, and I would not distribute that -8 at all. Okay, so just take it one step at a time, and you'll do just fine. Okay, All right, that is actually the end. So try your homework, please. It's in big ideas, and refer back to the video if you get stuck, or actually look at your chart and your notes. Good luck.